Welcome to the third half of our three-part video series on a negative lead, the positive lead, and the pre-charge circuit. In this video, we will finish up going over what it takes to connect the high voltage battery pack to an AC motor. All right, so here we have a high voltage battery pack. This is nominal 360 volts. And we want to connect it to this electric motor. So for those of you who are new to the video series, this is a transmission out of a Lexus GS450H. It has two electric motors in it. Sometimes I'll refer to it as a trans motor. But basically when I'm talking about my electric motor, what is in my truck, I'm talking about this transmission with two electric motors inside of it. This is a battery pack, and electricity is stored in it in the form of DC, direct current. This is an AC motor. Modern day electric cars, hybrid cars use AC motors. So we can't just take the leads off of this pack, and I'm going to touch both leads at the same time. You should never do this because this pack is disassembled, okay? So this is just 60 volts coming out of one module and another 60 at another. This is not combined, just letting you know before you tear me apart in the comments. I will be really careful not to grab both leads. You should never do that for safety reasons. But anyway, if this was all assembled like it's going to be in my truck, this would be yielding over 360 volts, 400 when fully charged. So we can't take this and directly connect it to an AC motor because it's like this pack speaks German and that thing speaks Japanese. There's no translation. We need an intermediate box. So for that, we use a box called an inverter, okay? Normally an inverter would have one high voltage connection going from it to the motor. Because we're using two motors, that explains the two orange cables. So this part is fairly stock, okay? We have MG1, motor generator 1, and then we have MG2, motor generator 2. We're just doing this as a quick demo here. Let's see if this will reach. Probably not. You get the idea. That would be connected to the MG2 port. All right. So when we get parts like I did from a hybrid vehicle, from a Lexus hybrid, certain parts will just connect using OEM connections, and that's what we have here. Now, if we take these leads and we connect them to the inverter directly, we've learned in prior videos the inverter is going to go boom, okay? The capacitor inside the inverter will see a charge of electricity and it will blow up. So we cannot directly connect it to the inverter. We need yet another intermediate box. So for that, we use a contactor box. You'll hear me sometimes refer to this box as a safety box. That is just a branding that BMW gives it, okay? It's like saying ping pong instead of table tennis, okay? So we get this intermediate box, and then the leads from the battery pack connect to this contactor box, which sits usually inside the battery pack itself, or as close to it as possible. And then another set of cables will connect the contactor box to the inverter, all right? I'm just gonna demonstrate here, just like so, okay? This is what we're trying to accomplish, and today's video will focus on what's inside of this black box, all right? It's called a contactor box, so obviously there are some contactors that live in here, but what else lives in here and how does it all work, okay? Let me regroup here a little bit and I'll be right back. Okay, so we have a lot to go over in today's video, so bear with me here. I'm gonna try to demonstrate in as simple terms and ways as possible. So I'm going to be removing some things off the screen just to declutter. So we really don't need to focus on this physical connection to the motor at this juncture. So I'm just going to disconnect that just to make it easier. Slide this bit off camera. And when using hybrid parts, sometimes you need to make modifications and not use them the way the factory intended to use them. So this particular inverter has been gutted, and I removed the top portion here where we used to connect the battery pack in its OEM fashion, if you will. Now we connect it in an EV conversion down here to the main bus. Okay, so let me show you what you can do and how you can achieve that. And part of this is going to be a review. A lot of you may already know this. I will sound like a broken record, but basically, I want anyone who watches this video to jump in and not have to go back 20 videos. So what I have here is what I'm calling standoffs, and these are just spacers. These happen to be out of aluminum. And we can argue till the cows come home about conductivity and that brass or copper or whatever is better. And sure, but we're talking about maybe an inch here. Now, these are deliberately too long. It's just what I have. Okay, so these are maybe 1.5 inches. But they're used to go in there just so that we can avoid making contact with the housing. And I've also went further, and I'm not the first one to do this, but I went ahead and heat shrunk them, and one is obviously red, one is black for positive and negative. So I'll be using these ones that are heat shrink. Also, you can notice I labeled my inverter positive and negative. Don't be too proud to label. I also labeled these. I'm not sure if the camera can reach, but MG1, MG2. So Toyota and Lexus call these motor generator 1, motor generator 2. Okay, so, and I just happen to have some old screws here, bolts. These will go in here, and then we'll be able to connect to the inverter. Wanted to show you that. Now I want to turn to what is inside of this box, okay? I've went over it a bit before, but we're just going to do a quick review, a recap here. And inside this box, and I happen to have one already opened up, we have these contactors, okay? They're identical, but we call one positive contactor and we call one a negative contactor. Now, there is more jazz inside that box, but we're just going to do a quick review and just talk about these contactors. The first little quick demo I want to do is I want to quickly physically connect the pack to the inverter through these contactors. Okay, I customized these cables. I cut off these plastic ends, and these, believe it or not, each one of these cables actually has 2 smaller ones inside it. Okay, so I crimped on some ring terminals so I don't have to deal with these proprietary ones. This makes it a lot unsafer, but a little bit easier to use. So I'm going to go ahead and connect both leads to the contactors, and then I'm going to connect the contactors to the inverter and be right back. So I have everything connected. I'm wearing rubber gloves, standing on the rubber mat, trying to be careful here because this pack is now live, okay? I measured and it's putting out about 345 volts, so no, it's nowhere near 400 and it's not fully charged, but it still has enough to give you a bad hair day, as I say. As you can see here, this is a negative lead. It goes to the contactor and to the input on the inverter. And then coming from this side, I'm using my laser pointer here, is the positive lead to the positive contactor and into the inverter. So This whole time I've been preaching that you cannot connect the leads from a high voltage battery pack to an inverter without using something called pre-charge circuit. So how is this working, or is it? Why hasn't the capacitor blown up inside of this inverter? And to let you know, I've measured the voltage on these terminals here to the main bus bar, and there is no voltage there. The reason for that is that these contactors are opened in their natural configuration, if you will, okay? Think of contactors like a drawbridge, and so it closes the connection and opens it. So right now they are open. So we're going to go over the details of how contactors work, how a pre-charge circuit works. But one thing that I'm going to do is I'm going to replace this high voltage battery pack with a single BMW i3 module just for my own safety, and so I can freely demonstrate what needs to happen. The module will put out 24 volts. I'll still use orange cables to kind of symbolize and represent high voltage. Obviously, I think there's like 8 or 10 of those modules inside of a BMW i3 to give us the nominal 360 or 400. But I hope you'll play along and just pretend that that is going to be our battery pack. So I'll be right back after I replace these with a single module. So here it is. Turns out this is actually 48 volts. I just measured. It's been a while, so I forgot how much nominal this was. But this will serve as our battery pack. And I'm just removing this plastic lid because it comes with these proprietary cables, and I rather just alligator clip on some leads for us as we attempt to use it. Now I am also going to go further and replace this inverter and essentially the AC motor with a simple DC motor. And you guys now might be tuning out saying, well, that's it, I'm bailing. This defeats the whole purpose of this experiment and this demonstration with an AC motor and an inverter. Well, the point of this video is actually about the contactors, and the meat and potatoes of today's video is actually about the pre-charge circuit. So stick around, trust me, hopefully it's going to make sense soon. Okay, so there is our simple DC motor, and having almost pulled off the world's greatest bait and switch, let's keep going. I'm also going to replace these contactors. These are the newer style ones. They are a little bit more robust and powerful. I plan on using these as backup in my actual truck, so I don't want anything to happen to them. And now that we've stepped down the voltage and we're going to be pulling less current, we really don't need these big and fat bulky cables. So I will move those aside as well. And we're going to be using contactors that look very similar. They're physically, they're about the same size, if not exactly the same size. I want to use these for two reasons. These are my spare ones, and if something were to happen, I'm not going to cry too much about it. We also don't need bulky orange cables or wires, so I'm going to just be using these with alligator clips on here. And another reason why I want to use these contactors is because I happen to have the pigtails for these, which are older style, a little bit different than the orange ones. I don't want to cut up another nice harness from the safety box just to use the pigtails. So I have these. So just simple factory clips, they snap right in there. And we'll get to what those do later on in the video. Okay, so I appreciate you sticking around and bearing with me as we set up this demo. And this is just a regular DC-DC motor. I'm using it instead of the inverter because if I was to run this example with an inverter, the inverter would do nothing physically to show us something is happening. The inverter wouldn't spin, bounce, light up, glow. It makes a very faint whining noise, but I doubt the camera would even pick it up. But this motor hopefully will spin. Maybe I'll put a little blue tape on here to really show you that it's working. So this is just to give you a visual. I considered using an incandescent light bulb, like a 300-watt one, but I don't want to confuse those who know that you can use light bulbs as poor man's resistors, because I don't want them to just glance at the video and think, oh, he's using that light bulb as the resistor, because no, I would have only been using the incandescent light bulb as the load, and because the light bulb would turn on and glow as we were making contact in the circuit or turning the circuit on and off. But I decided to use a DC motor. Okay, guys, so as I'm setting up my circuit, I want to show you this little doodly dudes that I'm going to be using to make the connections. Now, these are a little bit, where am I here? Too finicky for the wires. This wire's pretty big gauge, but yeah, this is what they look like. Maybe I'll put a picture on the screen. They're great for prototyping and kind of development work. I like the singles, so just 1-to-1. Okay, so the orange wires represent high voltage. This isn't really that high, but we're going to do a little bench test here, okay? Our first test to see what happens. So I have my positive lead already connected, and now I'm going to connect this one. Okay, so obviously the motor spins, and I didn't strap it down on purpose. I wanted to show you how violent that is, and we'll get to the reason why and how to avoid it. But it did exactly what I wanted it to do. Okay, so now we're going to introduce contactors into the circuit. Okay, we're going to introduce a positive and a negative contactor, and again, they are the same piece of apparatus. We just call one positive and one negative. So let me wire these up and I'll be back. So at this time, I've wired in one single contactor. I happen to put it on the positive lead. It could very well sit on the negative lead, and EVs actually have them on both. There's a positive contactor and a negative one. You could, in theory, just have one, but it's sort of the belt and suspenders level of protection. If you only have one contactor, and let's say the negative lead is just a solid wire, then there's no protection on that solid wire. And if one contactor fails, and by the way, unlike fuses, what I've observed is that when contactors fail, they weld themselves shut. So there's this gas encapsulated piston in there that's spring loaded, and I think it's operated by electromagnetism. And so it pops up, the piston pops up or down, however it works, and it makes contact. And if something goes south, something goes wrong, it welds itself shut. Sometimes you see people saying you can tap these contactors on like your floor or your workbench, and they may snap open. I've had some luck with that, but rarely. You haven't done an EV conversion until you really welded a few contactors shut. I'll post some pictures of me busting one open just to see what happens in there when they do weld themselves shut. But a top tip, when doing any type of high voltage work, always use your multimeter to check, because on your electric conversion, if a contactor fails, it's going to fail shut in the on position, and it's always going to be sending voltage. And so some signs of that are, if you work on your EV conversion on the weekend, then you go to work for 5 days and come back the next weekend, and you notice that your battery has been drained. Not a lot, but just some. That's because the contactor failed closed and it was pulling energy out of that pack, let's say. And this is, I mean, this is just a silly example, but it's sort of a theoretical example. And it's constantly draining the battery because there's like a drain resistor in the inverter, I think. Anyway, so we have our simple circuit here with an added contactor. Now we're going to talk about how to make it work. So there's the main wires, the orange wires here are the load. This here is just my negative. It just goes to this, I think this is like a universal motor. It probably runs on AC and DC. The color coding would imply that this is AC, white and black, as opposed to red and black. But I think there's three types of motors, like AC motors, DC motors, and universal motors that run on both types of electricity. There's probably a ton more motors. I'm just naming the three top of my head. Anyway, we're gonna talk about how a contactor works now. So these contactors sometimes come rated at for 12 volts, sometimes they come rated as 24 volts, depending on what type of, I think it's like a solenoid or something in there, what voltage it wants. But they will open and close with less volts than that. We're actually going to do a demo using 9-volt batteries, okay? So you could use a stack of double A's. Those of you who watch my videos know that I'm a junkie for double A batteries. So 8 double A batteries will give you a nice 12 volts, obviously less than car battery in terms of amps and power, but the right voltage. But I don't want to use this pack. It's just easier to demonstrate with a 9-volt battery. So I'm going to pop one of these open. And a single 9-volt battery could power both contactors. I bought 2 of these, so I'm going to use 1 per contactor just to make it easier to demonstrate. I also have one of these doodly dudes here that basically leads for a 9-volt. So you put those on here, and then this is where that earlier mentioned pigtail comes in, because a contactor has 2 types of contacts. The big wires, the orange wires, for us symbolize load, right? We want big current, high voltage going through that load, and then the skinny wires will show us symbolize logic, okay? So the orange wires are the muscle, the skinny wires are the brains of the operation. We're also going to use more doodly dudes for these connections. Again, I like the single one, so our yellow to red, and then the purple will go to the black, and I'm just going to touch it, and you'll see what happens. Now, this is going to be 9 volts going to a contactor. We should hear a click. I'm not sure we'll be able to hear it because this monster will probably start jumping. Okay, you saw that? So I wonder if I have my big clamps here. I think I do. Now that you've seen that that thing is violent, let's see if we can maybe sort of do something half intelligent on the show. Is this how it's supposed to work? Who knows? Let's see what that does. Okay, guys. So let's try this again. So we are here supplying, 9 volts on the low voltage side of this contactor, and that just, it closes that drawbridge. It closes the connection and opens it. Okay. Another purpose of the contactor, other than working as a switch, is a safety device, and it's to prevent arcing. Okay, that's why there's some sort of a gas in there to prevent the arcing, because I don't know if you could see it when I was just touching the leads together without a contactor. Sometimes these things would spark or arc if you just connect the wires. But anyway, so here's an example of a contactor. Let me wire in the negative one so that we get closer to the way our EVs actually look. There's going to be a positive contactor and a negative contactor. So let me add the second dude. Again, I'm using the ones out of a Nissan Leaf. I bought them on eBay. They were cheap, so I figure I grab them. They're great for demos. So let me add this guy. And now we have 2 contactors. Similar concept with this one. I have this little pigtail. This is the low voltage side, so that will snap right in there. And now watch what happens. Now we have 2 of them. We're going to connect the negative one first, because that's how it happens in the EV. And I will explain that further later. But first we're going to do the poor man switch here while we'll just wind these together. So you probably, on this one, you probably hear a click. Okay, so we get a click on this one. and we can hear it. On this one, we probably won't hear the click because that beast is going to come to life. Okay, so there we have it. This orange wires are our loads, okay? And then the low voltage ones, we're operating on 9 volts, but these are technically 12 volt contactors. It may actually say that on them. Sometimes that is in their model name. Of course, it's not on this one. I forget what all the symbols in the model number symbolize, but some of them are a hint whether it's 12 volt or 24. Anyway, the EV manufacturers like to use 2 contactors, so we have a positive and negative one. Okay, let me disconnect this one. And now I need to admit to you that so far I've been committing a cardinal sin of circuit assembly and building, and that is not using a fuse, okay? And I've been doing this just to demonstrate and keep things simple and less cluttered. But in addition to the 2 contactors that live in one of these safety boxes or contactor boxes, right? And we've been looking at these guys. There is also a fuse. So it looks similar to this one here, and it sits on a positive lead. This is a PEC 250 amp. The one that actually lived in here is a 350 amp. I yanked it to move it to the positive connector lead that I've built in a prior video. Again, part of this 3 video series. And then I went out and bought these. So I'm just showing you like what it looked like and where it sat. I'm actually going to do another bait and switch. And I'm going to use this cheap one. This is the Busman. It's 250 amps, 500 volts. Actually really nice fuse. And unlike contactors, when fuses fail, they tend to break the circuit. And these also have a second role, and that is to squash any arcing or prevent fires or sparks, if you will. So I'm kind of, I don't want to say I'm all over the place, but I'm doing these bait and switches to show you that as you get into the hobby, you can pick up some toys and you can pick up, aftermarket contactors or OEM contactors. And it used to be that wreckers would not disassemble a battery pack. And then over the years, the Leaf has been out more than 10 years. So they've gotten brave, and they now open up battery packs, and they will remove a contactor box out of a battery pack, and then they will now open up a contactor box and remove their contents, so you can get contactors. These came out of a Nissan Leaf safety box. Anyway, enough rambling. I am going to add this to our positive lead, okay, that's going to sit in here, and this is part of what I call appendages. So the positive lead has a fuse as an appendage, or what I call an appendage, and then the negative lead has an appendage, and it's a different one. So stay tuned, and I will show you what that one is. Okay, I'll be right back after I add that to our circuit. And there we have it. We now have a fuse in line on a positive lead. I did flip this contactor around. It really doesn't matter. I just kind of wanted to do it to declutter so you guys can see that from the battery, the positive lead goes through a fuse, then a contactor, and then it's going to go to what we call the load, in this case, our universal motor. Okay, so why am I going through this? Because one of the common things to do during EV conversion is to roll your own contactor box, okay? And even if you don't do it, it's important to know what happens in it and how it behaves. BMW calls it a safety box for a reason. It's not just for your protection from getting zapped, it protects the electronic components. So as we press through this and finish our detailed review here of operation of the positive lead and the negative lead, we'll actually get to the meat and potatoes, like I keep saying, of this video, which is the pre-charge circuit, and then it all should come together. Anyway, we know what's going to happen with the fuse in line, but just for funsies, here we go. So Poorman's switch on, that close the positive contactor, And then here I'm going to make the contact for the negative contactor. Well, that's cute. Is that making contact? This making contact? Not spinning. Could that be a bad fuse? What? What is happening, people? So that's on volts DC. We're going to measure the voltage coming into the contactors. And this is 15 volts. That's 46. So is that fuse acting as a big-ass resistor or something? Huh. $15 volts. Interesting. Okay, well, that was interesting. I replaced that fuse with one of these 250 amp, 450 volt PEC ones, and I've tested it off camera, so I know this one works, but I'm going to go through the steps with you here on camera. So poor man's can switch there for the positive contactor, and now we're going to touch the negative contactor. Our motor spins. So question is, what happened with the other fuse? Is it a bad fuse? Well, I don't know. I have a bag here of 3 more, and maybe we want to replace it and with a different one just for funsies to see what happens. Let's try that. If you know what's happening, post it in the comments. Let's get this guy out of here. Do fuses have polarities? Like, are they directional where you have to put it in a certain way? I don't know. So here we go. Let's replace it. As my buddy Super Dave says, 1 in a row is not a pattern. So 1 fuse doing that is obviously not a pattern. Let's see if 2 in a row will do it. I forgot which way I had that one in there. Oh well. But let's try it. This is why we experiment and we do this. So we find anomalies, or is it an anomaly like this one? Come here, you. Okay. So here we go. White busman fuse, take 2. First, the positive contactor, poor man switch on, and now the negative. What the hell, yo? This one be spinning. Did I buy a bad fuse? Okay, so maybe we should like test the resistance of this dude or something. Okay, we have this thing on ohmses. Come here, you. So 20, well, let's call it 30 M's. You guys, shouldn't a fuse beep? That's crazy talk. Let's try another one. Ha! I didn't plan this. This is BS, making me look stupider than I already am. This is a bad fuse. I mean, if anything, it should beep. Put this guy over there. Let's see what the resistance of this one is. Stop beeping for a second. Okay. So it's like 0.2, 0.1, not 30. Okay. You know me, not too proud to label. So this, I'm kicking myself for not testing right when I bought them because, you know, it's been a while since I bought these fuses, but they were so cheap. Bad. Okay. Well, we learned something. Okay. So what we're going to do now, I'm going to put bad on this box too so I don't pull it out and try to use it. Okay, so now we're going to move on to the negative contactor and its appendage. So something goes in here, and can you guys guess what that could be? All right, so once again, in our BMW contactor box, there is a current shunt. Now, this one comes integrated or connected to a circuit board, okay? But we can still put it in line, and unlike a contactor and unlike a fuse, a current shunt or a current Hall effect sensor, they don't control the flow of electricity. They just pass it through and they measure it, they analyze it. This will give us the current reading, the amp reading, and also the volt reading, right? And there are what I would say like two different types of these shunts, if you will. This one here is OEM, you know, original equipment manufacturer, and it's very similar, but here is a what I call an aftermarket one. So this one is German, and it's we call it ISA. On here it says Isabellenhut, and I completely probably mispronounce it. This is an amazing piece of kit. It can measure, I think, 3 voltages over here, and then it measures the current. So I could put this one in line, but just because we're kind of keeping up with using the stuff out of this box or as much as possible, I'm going to put this one and see if it works. I think it will work. I mean, it's attached to a circuit board. That shouldn't matter. So let me add the current shunt on the negative contactor, and the pieces of the puzzle will be coming together. And I promise you, after I do that, the next thing is the meat and potatoes of this video, which is the pre-charge circuit. And now we've added another appendage to our circuit here. So we now have a current shunt in line. I'm not sure if you can see on camera, but I drew an arrow on here because, again, I am not ashamed or embarrassed to label. And unlike a fuse or a contact or maybe even a resistor where you can flip around, a current shunt is directional. It needs to go a certain way or it's going to read negative amps, negative current rather than positive current. And we want to know which way is which, because when we're driving, we're going to be pulling amps, but when we're running regen, we're going to be pushing amps back into the battery pack. So anyway, this is directional. Here it is in line. Hopefully you can see that. So our negative goes through the negative contactor, positive through the fuse and the positive contactor. In the EV, the negative contactor makes contact first, so I really should start getting in the habit of connecting them in that order, and later you'll see why that makes sense. So poor man's switch on, and now the positive contactor. And our little beast here, I don't know what that is out of. Is that out of a vacuum cleaner? My friend Ed gave it to me and said, hey, you can maybe use these for your demos, and I absolutely love that silly thing. Okay, before we move on finally to the pre-charge circuit, I want to share one more thing with you, and that these contactors are economized, or they have economizers in them. There's non-economized and there's economized contactors, and then there's internally economized and externally economized. So I'm the last guy on earth to explain what an economized contactor is, but that won't stop me from explaining it. So I'm going to explain it using one of my worst analogies yet. So here we go. So turn your attention to my garage door, okay? This garage door is open just like a contactor is open. This garage door represents a contactor, if you will. It's silly, I know, just stick with me. So there's a gust of wind and it blew my garage door open, and I am going to close the contactor. So watch me close it. Okay, what happened there? To close the contactor or the garage door, I initially need to use a lot of energy. And it's all relative, but let's say we're using our little contactor there. It runs on 12 volts. So let's say to close it, it uses 12 volts and 1 amp. I'm not even sure if I'm in the ballpark on that, but that's what I'm showing here. Or let's say it's using 2 hands, like the way I closed it with 2 hands, so 2 amps. It uses 2 amps to close it. But once it's closed, notice I was holding it shut, closing the contactor or my garage door with 1 hand, because now I don't need that much energy to keep it closed. So I can go from 2 hands or 2 amps down to 1 amp to keep it closed. Or maybe later when I was using a finger, just a fraction of an amp to keep that contactor closed, or in this case, this garage door closed. So yes, it's a silly analogy, but the point is that it takes more energy to close that contactor, but it doesn't take that much to keep it closed. And why does that matter? Well, enemy of electricity is heat. Electricity has many different enemies, but one of them is heat. And think about it. When we go for a drive, we can drive from San Francisco to LA. I mean, Sameh Haggard says it took him, what, 5 hours? It can take hours to get there. During that time, the negative contactor needs to remain closed. The positive contactor needs to remain closed. So if they're not economized, then they are using a lot of energy. A lot of energy relatively. I mean, they're not using 200 amps. They're using milliamps, but still, it's enough to warm these guys up. They're encapsulated in plastic inside of another plastic safety box, inside of a metal battery pack box, and heat is building up in there over time. So economized contactor means that it will use a lot of energy to first close itself, close the contact, but then it will step down that how much current it needs to keep it closed, okay? And those guys internally economized, I mean that the intelligence to make that happen is all inside that contactor, or they can be externally economized where there's some sort of an external circuit board somewhere inside the safety box, inside a contactor box. Heck, maybe the vehicle control unit or the PCM is controlling the signals that go to that contactor. Maybe it's PWM controlled, I don't know. However it's controlled, it can be done externally with a separate logic board or internally using whatever voodoo magic, okay? I believe these Panasonics and my Orange PEC contactors are internally economized, but if you're building your own contactor box, it's very important to use economized contactors, whether internally or externally, somehow economize contactors, okay? So that's the last tidbit I want to leave you off with. Now we're going to move on to the pre-charge circuit. All right, guys, so now we've come to the meat and potatoes of this video. Thank you for sticking it out with me. So we essentially know how to control the negative lead and the positive lead, and eventually that will get us moving up the road. But if we close both contactors right now, and if we had our inverter here, we would blow up that capacitor. So we need to slowly build up the current and the voltage inside that capacitor. And the way to do that is to use yet another component found inside of this BMW safety box. And that is a resistor. And this is a quite large resistor. And I want to say this is 15 ohms, okay? But I'm too lazy to double check, so I'll just be saying a wrong spec. And forgive me, but if I'm right, I'm right. So where would we place this, right? We could put it, let's say, on the negative lead, all right? If we were to install it there, and then we would close the negative contactor, and then we would close the positive contactor, we would basically observe the current and the voltage slowly building up. And technically, I believe we would achieve pre-charge, okay? But we would have no drivability, all right? So, well, okay, well, let's put it on the positive lead. All right, so again, we close the negative contactor, then we close the positive contactor. Similar thing, really. We achieve pre-charge. We start pre-charging that capacitor inside that inverter. But the pre-charge, may finish, may last to infinity, whatever. We never get enough current and voltage going through this resistor to drive the vehicle, because that's essentially what this resistor is doing. It's kind of funneling the amount of electricity, amount of energy or current and voltage that can flow through our circuit. So what I'm trying to say is that we need yet another path, a third path for this pre-charge to happen. So now if we think about it, let's think about it where we would install this resistor, okay? We could pull it from the positive terminal, right here. But if we do that, we lose fusibility, right? We could get clever and say, well, we want the pre-charge circuit to come off of the fuse. And that way we kind of kill two birds with one stone. We protect our pre-charge lead with a fuse, and we're also putting a resistor on it so that we are trickling in some energy into that capacitor. So we could put it, after the fuse, right? Then if we think about it even some more, why not pull it right off of here, okay? Something that you're not really seeing here, getting the concept of, is that these orange wires are really thick and bulky, and actually inside of this contactor box, there's a big fat bus bar that runs right here. So it really makes sense to start your pre-charge at this terminal of the positive contactor, because you get all of this is already built out for you, and it's actually big fat orange high voltage cable, a nice 350 amp fuse, then a nice thick bus bar, and so we really can tap into here, okay? We tap into here, and it's on the positive lead, and then it goes to the resistor, and then from the resistor, it run to the motor. Well, if we did that, it could work, because although that would be a permanent connection, essentially from this fuse side to the resistor right here, and then from the resistor to the motor, it would work, because the negative contactor would be open when the car is off, and then we would close it only to drive, okay? So there wouldn't be any danger. Now, we wouldn't have the safety that if the negative contactor gets welded shut, then our resistor, the pre-charge circuit, would still be live, okay? It will be trickling in some voltage, and And sure, it's not going to get up to maybe 400 volts, but it could get up to 300 volts, right, as it's pre-charging that cap. But let me work this into a circuit here, and let's start seeing what is happening and how this will work. So I've built a couple additional leads here for our pre-charge circuit. I know it's hard to notice this on camera, but these are thinner wires than the ones that we're using here for the load, for the negative circuit and positive circuit. And I mean, technically, we're talking about a difference of this for the load versus these. These are maybe even slightly thicker. I would say these are maybe like 14 gauge, I don't know. So there are maybe even slightly thicker than what's in the safety box, but they're definitely significantly thinner than the actual load wires, if you will. So to make things even simpler, although we have built a positive circuit and it will come back just the way it is, I want to temporarily remove it just to make it more easier to see what the pre-charge circuit is going to do. So we can remove its low control. We can actually remove this positive lead coming off of the contactor. This is the lead that comes off after the contactor is closed. We just don't need it at the moment. And we could, what I'm trying to show you is that for this example, we could literally just connect this to the negative, to the resistor, and then from the resistor to the positive of the actual motor, okay, we could just have it like this, all right? And then if we made this connection here, if we close the negative contactor, this would start pre-charging essentially our capacitor inside the inverter. Another way, you know, I could join these as basically just screw these together right here. But I'm just going to continue using this positive contactor. Essentially, okay, that's what we're doing. We're just kind of using it as a junction block, I should say, okay? It's sort of just a junction block. We're just borrowing this terminal so we can screw two wires together. That's all it is, okay? This contactor is not opening or closing, okay? But I insist on doing it this way because this is how BMW actually does it, okay? So here you can see we have the resistor. So fuse, just touching the positive contactor, it's not really doing anything in this example, through the resistor to the motor here. I'm going to go ahead and close the negative contactor. And really, to see the difference, I'm going to free this guy up. I want you to recall how violent this thing was before, and now watch what happens. See, we are slowly giving it some juice, okay? Slowly, not all radically and all at once, right? So that's what the resistor is doing, okay? Now, I'm not going to get into actually putting a multimeter on here and measuring anything because I want to actually finish this video. But so this is an example of, you know, one way this could work, but we never end the pre-charge here. So I'm showing you this way on purpose to kind of build up our knowledge, because the pre-charge circuit inside this safety box that I keep on bringing out, the pre-charge circuit, instead of using a contactor, it uses what I call a baby contactor. It uses a relay. It uses a pre-charge relay, and a relay is just a smaller version of a contactor. it may be able to handle the same amount of voltage, 360 volts, 400 volts, but it sure can't handle as much of the current. So it's rated for a lot less amps to go through it. And so let me bring one out of those. Okay, so here it is. Now this looks more like an automotive relay, right? The automotive relays are 12 volts and like 20 amps or 40 amps. Now this is higher voltage, but it's nowhere as big as our contactor. But this is what is used in the pre-charge circuit, is a relay. And where does it sit? Well, it sits after the resistor. So whereas the negative contactor has an appendage of a current shunt, positive contactor has the appendage of a fuse. A pre-charge contactor, essentially a small relay, a small contactor or a relay, its appendage is this resistor. So it would really go more like this, okay? And that's what I'm going to wire up next, and so that you guys can see what the pre-charge circuit actually looks like. I may even, for demonstration purposes, ditch this contactor. So let's build out the pre-charge circuit, and I decided to completely get rid of every component of the positive lead, so we have no more positive contactor. We don't have its little 9-volt battery to control it, and that's deliberate because I want to just start with a nice clean canvas here. And so we are borrowing the fuse. So from the fuse, the load, notice these are orange wires, so they still carry the load just like these ones, which are supposed to represent the really fat ones. Something that I don't see on these cables is color coding. So as you can see, I like to use a red heat shrink to symbolize positive, because the pre-charge circuit is a positive lead. It's scaled down, so it's using orange load cables, high voltage, but low current, and it's using these red heat shrink. On this relay, there are usually 2 fatter terminals and 2 skinnier ones. The fatter ones will be our load, and the skinnier ones are the controls. I'm not sure if it matters as long as the fat ones go together and the skinny ones go together. Okay, so sorry. So basically, it goes fuse, then it's a pre-charge circuit appendage, which is the resistor. Then from the resistor to the relay, the relay just uses blade terminals instead of screw-ons, so that's another little difference. And from here we go out of the relay and using our little clicky clackers here into the motor. Okay, so now as long as we supply some low voltage, 12 volts, to these skinnier terminals, the control terminals, this relay would close its contact and allow current to go through. It's going to be going through a resistor, so it's going to be lesser and it's going to slowly start building up. But this motor, in theory, should start spinning. I made some leads for these guys and just keeping it simple. Red lead just to show you that this is DC, and the black lead for a DC negative. And then we're going to bring our buddy back. We're going to borrow the 9-volt battery from the positive contactor just temporarily. We're hooking up our positive control lead here, and then since we don't have a switch, we're going to touch the negatives. And this is how it works in the car, okay? So in the car, both of these come to life at the same time. I can't do that because I don't have 4 hands, but and I don't want to rewire it just so I can accomplish that. So I am just going to simulate it best I can. But the pre-charge circuit shares the negative lead with the positive lead circuit. So there's only one negative lead, one negative contactor, one current shunt, and that accomplishes both tasks of doing the pre-charge and then later powering our vehicle. So we are going to make close the negative contactor. So it's closed, and in the car simultaneously the pre-charge relay would close as well, and we start the pre-charge immediately. So notice the motor started out slowly as the pre-charge was building up, and it wasn't all violent and all jumping around, okay? When it comes to starting your electric vehicle, your EV conversion, and you're doing this contactor box and you want to set up your pre-charge, so I say it's a two-step process. It takes two to tango, if you will. This first step is easy, okay? First step is really simple. It's like Neanderthal. It's just wiring, right? There's really not much logic. As soon as you turn the key to on, or as soon as you were to press the start button, you will immediately send 12 volts to the negative contactor to close it. And at the same time, you're going to send 12 volts to the pre-charge relay to close it. So the negative lead gets closed and completed, that circuit gets completed, and the pre-charge circuit gets completed, and we're starting the pre-charge. Okay, so then what happens? Well, then it gets trickier because there needs to be some sort of a delay, or there needs to be some sort of a feedback or intelligence, and that's where the current shunt comes in. Whether you use the safety box, if you use the safety box, it is CAN bus controlled, CAN controlled, and BMW did the work for you, and then Damien McGuire and the folks at Open Inverter reverse engineered it. This circuit board with the current shunt lives inside of this safety box, and it basically, you use the vehicle control unit, the aftermarket brain for EV conversions, and you set there what voltage you want the pre-charge to get to before we close the main contactor. So step one is we close the negative contactor and close the pre-charge relay. Then after some point in time or a certain amount of voltage rising or a certain amount of amps, then we close the positive contactor and we open the pre-charge relay. If you were to roll your own, you can do this a couple different ways. And again, this is one of the reasons I'm going through this painstaking process, is that you don't have to use the safety box, the actual BMW safety box. Not all contactor boxes have intelligence in them. The BMW hybrid contactor boxes called safety boxes do have intelligence in them. I believe the Nissan Leaf ones don't, but they're not bad. I actually like those boxes because you can use that OEM box, the hardware, to do your own pre-charge control of it. And the beautiful thing about the Zombie VCU, vehicle control unit, offered by Damien McGuire at evbmw.com with help from the Open Inverter community, that VCU can control some contactor boxes. I'm mispronouncing Volkswagen Audi Group, I think. It can control that one. I don't have it. Actually, it's a reminder. I want to go out there and get that box so I can do some videos on it and learn about it. It can control the BMW S boxes that come from a variety of BMW hybrids. And also, it can control your own. If you were to make your own contactor box, it would control it. Again, you would tell it, sense the voltage. And if you have a 360 volt battery pack, sense the voltage and don't close the main contactor till it gets, let's say, 300. Now, some would argue that you want to set it within like 10 or 15% of your max voltage. Maybe that setting could be dynamic. I know that there could be like a catch-22. Imagine if you have a 360 volt nominal battery pack, you charge it to 400, right? And let's say you set your pre-charge to be at, let's say, 360, okay? So you get in the car and you go for a drive, and as your battery pack voltage drops, as you're consuming that energy, let's say your battery pack is at 355 volts. Well, the car's still running and driving. Of course, you can drive because it's already started. But then you pull over to the side of the road and you turn off your car. And now you have 355 volts in the battery pack, but your precharge is set to 360. So as you go to start, your VCU, vehicle control unit, will never issue a signal to close the main contactor because it's waiting for the voltage to get up to 360. So be careful what you set it. And I might get in trouble for what I recommend, but I think mine is set to like high 200s or 300. So my threshold for driving is I use voltage as my fuel gauge. And something I want to introduce to my video series is a segment called Unpopular Opinion. And it's where I share opinions that are so unpopular I don't even like them, but that won't stop me from sharing them. So one of the unpopular opinions that I have is that you can use the volt gauge, your voltmeter, as a state of charge. And I do some tricky stuff with the help of a friend, Arthur Kustuch, who did the Jag. He helped me set up the fuel gauge to basically work as a state of charge gauge. So what we do is we say, okay, if full charge is 400, subtract 300 volts from 400, so that takes you down to essentially 100 volts. And 100 volts then means 100% charge. And as I drive, that thing's dropping down to 300. So at 300, 300 minus 300 is 0. So then I am completely depleted, if you will. So I watch that, and we subtract 300 from 400 volts or 350 volts or 300 volts because the stupid fuel gauge, I think it's only 2 digits, right? So that way it lets us read out what it says. So if I charge my pack to 393 volts, let's say, it's going to say, okay, you're at 93% state of charge, or that's your fuel gauge reading. And it's ballparkish. I mean, not even the true OEM state of charges are super accurate, and they vary depending on your drive habits and whatever. But I use voltage as my fuel gauge, and a lot of people probably use the current shunt or Hall effect current sensors to measure how much energy goes into the battery pack versus how many comes out. I just use the volts. Anyway, so at this point, we're moving right along. This is what the pre-charge circuit looks like, but it also has to operate with the main positive circuit. So let me add that back into the mix and rewire this a tad bit so we can see how it all comes into play. And okay, guys, so we're gonna be reintroducing our main contactor into the mix. And these are all your choices where you can pull your pre-charge from, right? Obviously, it's got to eventually come from the positive battery terminal, but at least grab it after the fuse so that it's fused, okay? And, you know, BMW gets it before the contactor is closed, so like the input to the contactor side, and that makes sense. So let's see if we can grab it there. Let me redo this real quick. Basically going to reconnect we're reconnecting the fuse back to the positive contactor so that this is going to be our main lead back into the contactor. And again, imagine these being, come on, way thicker wires, right? Okay, so this brings voltage to the input of the contactor, and we are just going to tap into that to pull electricity to the resistor. And we're doing that just so that we can use this guy as a junction block. Okay, so, and this is how BMW does it. So if you think this is clever, it's not me, it's how they did it. And it's a nice piece of engineering in that confined space, so they had to use some clever ways. Okay, now we need to continue this lead to the actual motor, and I'll show you how this then gets rerouted as well. Okay, so this is another clever thing that they will do, okay? So rather than going from the pre-charge to the motor, the pre-charge goes to the output side of the contactor, okay? And then it jumps onto the main lead. Okay, I hope you guys follow this because this is really cool what they're doing. So it's like a bypass, you know, it's like a bypass surgery or something like that. Okay, so these are our main load, and when the contactor is closed, this is how energy is going to flow to our motor here, or in our EV to the inverter, okay? But when the contactor is opened, it goes this way through the resistor, through the pre-charge relay, and then to the output side of the contactor, just borrowing its terminal as a junction block, but then using that thick wire to go out. So this is really clever. I really like this. This is pretty slick how they did it. Then we will go into here. And actually, what I should do, and I think I am going to do it. This reminds me of why I ran these so long. I am going to reroute the controls to use the negative battery so that when we make contact with the contactor and that, we will close them both. Okay, so let me do this really quick. It would look something like this. Okay, this is turning into spaghetti, but just hear me out. Here's what we're doing. I basically have the negative leads of the controls for the negative contactor and the pre-charge relay, and I'm just going to share a battery over here. Okay, so here we go. We are going to make this contact. And then now, can you guys tell? Wow. Okay, that is pretty cool. I thought it was already zooming when I just made contact with the pre-charge circuit and the negative contactor, but that's nowhere near as powerful as when we actually make the main positive contactor close as well. So watch. I hope you guys can hear that. Okay, let me go one step further and actually set this up so that what we're going to do, and it's kind of hard again because I'm just connecting wires, but the negative contactor and the pre-charge relay close at the same time and the pre-charge starts, and that's step one. And then when I make the positive contactor close, at that same time, I should disconnect or open the pre-charge relay, but it's hard for me to kind of do that on a workbench just with wires. So I'm going to do it as a step like 2B. I will get another one of these doubles, and I'm going to then disconnect the pre-charge. Okay, so here we go. This is, if all goes well, this is going to be the last time, so you guys are almost done getting tortured. So here we go. This is how pre-charge works. So get in the car, you turn the key to the on position, or you press the start button, and at the same time, the negative contactor closes and pre-charge starts. All right. Then, after a certain voltage is achieved, let's say, the main contactor closes, and the pre-charge gets disconnected. Yay, we did it. It's working. All right. Now, if I was to, let me show you that without the pre-charge, okay? So here it is, just as a reminder, no pre-charge. See that? This thing went berserkers. Thank you guys so much for watching. I hope you found this beneficial. I actually learned something tonight, just how this was wired to the contactor myself, using it as a junction block. I kind of just skimmed over it. There's really something for doing things hands-on, guys, not just reading, not just watching YouTube videos, eating potato chips on the couch. So be safe, but get out there and do it and try it and have some fun with it. Even if you never get to the point of a driving vehicle, I'm not saying you can't, but you can have some fun experimenting and doing stuff. You can be smart about it and not use 400-volt pack and just use, 48 volt or 24 volt or whatever you want to do. So again, thank you so much for watching. I hope you found this beneficial. Next video after this, we're putting the battery packs in the truck. I promise you that. And I hope to be driving that truck this summer. Thanks for watching.